specifically page 463. This is going to wrap up our conversation, or at least lead into a next conversation on what is the right amount of material or information to know about two triangles to say whether or not they're similar. And in the first question, in order to answer it, I'm going to use our tracing paper from the previous lesson, or just some extra stuff. Remember, if we have the tracing paper available, that can be the first way that we check, just by seeing whether or not the corners of the different angles, like, angle M, angle L, angle N, if those two corners fit perfectly into the other ones, and this one won't. I mean, it's fairly clear that angle M and angle Q should match, but they don't. And so I guess ultimately, to answer this first question, question 5, part A, each triangle shown as an isosceles triangle, determine whether you have enough information to show that the two triangles are similar. No, there's not enough information. In fact, when I traced the first shape, and that's a triangle MNL, and then I translated the trace over, it turns out that no, they don't actually match up. There's not enough information. Now, we're able to do this part, though. There's two single spiked sides of this triangle, and there's two double spiked sides of the other triangle. So if you take these sides and make a fraction of them, that's ML over QP, it would be the same fraction as MN over QR. However, because there's not a third fraction, that is the third side of the triangle, there's actually just not enough information. And we don't know what that third fraction would be. We don't know that these two sides are actually the same. And so I'm going to put 3 spikes and 4 spikes, just to let me tell you, and you to tell your geometry diagram, that they're definitely not the same. Now, in the next one, I'm going to go to part B, and I'm just going to, again, trace the small triangle. So I'm going to trace TS, TU, and SU. And then I'm going to take that trace, and I'm going to move the translation to another location. And look, angle V is the exact same size as angle S. Angle X is the exact same size as angle U, and angle W is the exact same size as angle T. Because of what we did in the previous video on angle similarity, yeah, I have my tracing paper that shows the angles are all matching and line up. We're not told that there's angles that match. We are told a side, and an angle, and we have corresponding side, and an angle. However, yes, this is totally the case. It's the angle that lets us show the triangles are congruent. Yes, because of the angle, and that angle is between the two sides. Oh, I even have the space to write congruent. Sorry if you don't. Congruent. The triangles, I'll use a triangle symbol, are similar. And that squiggle tilde sign is the shape, the symbol for similar. Some questions to consider. How would you prove the other angles are congruent? I mean, you could do what I did. You could do trace, not that one, trace and translate. And when you trace and translate, they actually do make congruent angles. You could also measure the angles directly with a protractor. And when you get the value of this angle S measurement, you can move the protractor over to angle V and confirm it's the same value. By checking their measurements, that's another way to demonstrate the angles are congruent. Thank you for watching this episode. It's been page 463. Next up is page 464. We're continuing our journey on what shortcuts we need in order to show triangles are similar. So like, comment, and subscribe, and see you in the next episode.